Reflecting functions across the x and y axis are an important mathematical process that will be explored in this lesson specifically for parabolas, although the general ideas can be applied to other functions. The first exercise gets at both of these important transformations. So the parent function x squared is graphed below, and we want to graph using our calculator what the graph of negative x squared will look like. So in your calculator, I have to pull my note. And you're going to go to y equals, and all you're going to type in is exactly how it's written on your paper. So let me go to y equals. Y equals, and type in negative x squared. And hit graph. When looking at it, what's different from the original? Yeah, it was flipped over the x-axis, so when we graph it, again, you can use your table and your calculator to help you graph this time. So plot as many points as you can. If you look at the table in your calculator and plot those points, it will look like this. 0, 0, negative 1, negative 1, negative 2, negative 4, positive 2, negative 4. So it looks like this when you graph it. Yes? And as Ben said, we flipped or reflected over the x-axis. So now what we're going to do is graph the negative x, but it's the negatives now on the inside with the square. So we're going to go to our calculator, go to y equals, and type in the negative x, close parentheses, squared in your calculator. It looks like that. Hit graph. When we hit graph, what does it look like happen? Anything change? No, it didn't. It just looks wider from what's in our calculator to what's on your paper. But no, nothing really changed about it. Okay? But something technically did happen. Alright? It did reflect over something. What do you think it reflected over? The y-axis. Very good, because the y-axis is going right down the middle of that graph. So when you flip it, the opposite points end up mapping up with each other, and you get the same exact graph. Okay? So yeah, it looks like nothing happened, but technically something did. It was reflected over the y-axis. Okay? And also you can think about it, how we have like negative x squared. Well, what happens when you square a negative? It turns what? Positive x squared. So that's why it technically looks like it didn't change, because then you simplify it down into some graph. Okay? And that is true every single time the vertex is sitting on the y-axis, and you flip it over the, and you reflect it over the y-axis. It just kind of stays exactly how it is. Okay? Questions over that? That's only for quadratics. Other functions, it's a little different. So we take a look at example 2. Okay, the parent function for the square root function, radical x, is shown below. We're going to graph negative square root of x in our calculator, and we're going to see what happens. So go to y equals. We're going to type in negative square root of x. And again, when we look at it, what happens? It flipped over the x-axis. And again, you can use your table. You hit second graph. Use your table and plot those whole number points. And when you do that, it ends up looking like this. 0, 0, 1, -1, 4, -2, 9, -3. So that blue graph is our flipped graph, okay? And it, as we said, it reflected over the x-axis. In our calculator, we're now going to put that negative on the inside with the x. Right, so go to y equals. Now the negative is going to go on the inside with the x. And then we can graph it. What does it look like happened when the negative is on the inside with the x? Yeah, it reflected over the y-axis. And again, you can use the table in your calculator. You can do second table to get those nice whole number points. And when you do that, when you plot those whole number points, your graph will look like this. 0, 0, -1, 1, -4, 2, -9, 3. So it looks something like that when you use your table in your calculator to graph those points. Questions over that? So you maybe have noticed what happens depending on where the negative is in a function. So when the negative is on the outside of the parentheses, okay, there's a reflection over which axis? The x-axis. When the negative is on the inside of parentheses with the x, there's a reflection over the y-axis. So we could now fill this in our transformation chart. So we're going to fill in these two. We filled in the first 4 in the last lesson. Now we can fill in these two. So based off what's written, what's this saying for us to do if it's negative f of x? Or, yeah, it's a reflection over the x-axis. The second one, the negative's on the inside with the x. So the example, the negative again is on the inside with the x, negative x squared. What type of reflection is this? Yeah, reflection over the y-axis. So whenever the, did I spell that right? Whenever the negative's on the outside, we're reflecting it over the x. Whenever the negative's on the inside, we're reflecting it over the y. Outside x, inside y. Questions over that?
Do you students have like Valentine's with
So if we take a look at the back, we flip it over to the back. We are given a quadratic. We want to state the vertex, the transformation, and then sketch a graph of it. So we take a look at this first one. What is our vertex? Yeah, -3, -1. The x, the number on the inside is our x, change the sign. The number on the outside stays the same, and that's the y. When we do transformations, we always read our equation from the front to the back. Okay? So we start at the front, and I notice there's a minus sign out in front. Reflection over the x-axis. Good. So we're flipping or reflecting. So when they say don't abbreviate, don't write like r over x-axis. At least write out the word reflect. Don't have to write out the word reflection, but spell out the word as best you can. Don't just put like, we've had students who went like U3. So you have to understand that's like up 3. So just spell out the words. So just don't abbreviate so we know what you're talking about. Okay? And then keep going on the inside, we're adding. So that means good. We're adding on the inside, that means opposite. So we're gonna go left 3. And then we're subtracting on the outside, so that means we're gonna go where? Down 1. So then we can just do a rough sketch. Right now, later on, we'll get into more serious sketching where you have to shift. But right now, we're just going to do a rough sketch.
There's another one I forgot.
Okay. So when we do a rough sketch, just right now, you can type it in. Go to y equals and type it in. We can do, what is going on? Negative x, oh my gosh. My cardboard's not cooperating. So we can do x plus 3 squared minus 1. And then just use your table to plot it. So just a rough sketch for right now. We'll get into more serious graphing later. But then you just, again, go and plot those as many points or few points that can fit on your graph using your table. And when you do so, your graph should end up looking like this. Your vertex should be at -3, -1. In which direction should our graph open? There's a negative on the outside, so which direction should it open? Oh, yeah. So when you plot those points in from your table, it should look like this. My smartboard is really off. Sorry about that. So we'll be fine for a little bit, and then it just doesn't want to cooperate. Okay. Questions over that? And as you can see, the vertex is where we said our vertex was, and it's flipped, so it's opening down, and it shifted left and down from the original. Okay. So we take a look at B. When we write our vertex, is there anything being added or subtracted with the x on the inside? No. So what's the x value of our vertex? 0. What's the y value of our vertex? 4. Okay, so when we do our transformations, always start from front to back. I notice in the front there's a negative on the inside with the x. So what transformation did we do? Yeah, we reflected over the y. Reflection over the y-axis. We said there's no horizontal movement because our 0 is the x value of our vertex, but we're plus 4. So we're going to go up 4. Okay, so which way should our graph open when we graph it? Yeah, it should open up. So let's see. Let's go to y equals. And the reason why it opens up is because the negative's on the inside. So that doesn't change the way it opens. And the negative's on the outside. That flips it down or back up. So when we, again, use your table, second graph, plot those whole number points that will fit. You don't have to do every single one. Do like 3 or 5. Right? It's going to look like this. So your graph, after you graph it, should look something like that. Okay? And again, you're like, well, that didn't look like it flipped over anything. Because when the vertex stays on the y-axis when you flip it, it's pretty much the same thing. Because the y-axis is going right down the middle of the graph. So all it does is this really just takes the graph up 4. So it kind of stays the same orientation as the original. But you still have to write that we reflected over the y-axis because we technically did. It just, you can't tell. Okay. We take a look at this last one. Go front to back. In the front we have a negative. Is the negative on the inside with parentheses or on the outside? Yeah, it's on the outside. If there's no parentheses around the negative, it's technically on the outside. So what is type, before we do that, sorry, what's the vertex? What's the x value of vertex? 0, because there's nothing being added inside with the x. What's the y value of our vertex? 6. So we said that our negative is technically on the outside of the x squared, so what type of transformation did we do? What do we reflect over? Put over the x-axis. Right? What's our next transformation? Up 6. There's no horizontal movement because our vertex is 0, the x value, so we just went up 6. So when we graph this, which way should our graph open? downward because we reflected over the x-axis, so it should be opening downward. So again, when you look at your calculator, go to y equals negative x squared plus 6. Again, use that table to plot your points. It's going to look like this. Vertex is at 0, 6, and it should be opening downward. And you plot those points. Should look like that. Questions over that? Yes. Negatives on the outside, you're reflecting over the x. And on the inside of the parentheses, you're reflecting over the y. Outside is x, inside is y. So we take a look at this graph, okay? It's already been translated for us, but now we want to reflect the translated graph, okay? First, on reflection we're going to do is a reflection over the x-axis, and then we're going to take it and reflect it over the y-axis. So it's really helpful we first write a formula. So where is the vertex at of the original graph? Where's our vertex? It's the x value of vertex. What type of 2? Negative 2, good. What's the y value of a vertex? 6. Right? So we write this in vertex form. We have y equals, right? X is on the inside. Our x value of our vertex is negative 2. So when we write it inside the parentheses, it's going to become positive 2. Good. We have a positive 6 on the outside, so it's going to become plus. Good. It stays the same. Which way is our graph opening? So we're up or down? Down. So whenever it's opening down, it needs to be out in front. A minus sign. Okay, because that means from the parent function, it reflected the parent function over the x-axis. Okay. So that function that is graphed for us has to have a negative out in front. So now what we're going to do is reflect this graph over the x-axis again. So when we do that, you're going to think back to your geometry days. All you're going to do is count. You're going to see how far each point is away from the x-axis and count that amount in the same direction. So if we start with our vertex is 1, 2, 3, 4, 5, 6. So then you're going to count 1, 2, 3, 4, 5, 6 away from the x-axis. You're going to do that with all the other points. This one is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 2. 1, 2. And these ones at the bottom here, that one and that one, okay? Yeah, they're on the opposite side as everything else, but you're still going to count to see how far it is away from the x-axis, and then count again. So these bottom ones are 1, 2, 3 away, so you're going to count 1, 2, 3. 1, 2, 3, 1, 2, 3. And when you connect, it should look something like this. You're just counting like you did in geometry when you reflected a figure. Okay. So when we write a new equation, we write it as y equals, it might be helpful to you, what's our new vertex? So the purple graph, what's our new vertex? Negative 2, negative 6. So we write our equation y equals x what? What's going to go on the inside with the x? If our x value is negative, plus 2. What's going to be on the outside? Minus 6, because that sign doesn't change. Do we have to put a negative out in front? No, because our new graph is opening up, so we don't need that negative anymore. Okay. So when we go to the next one, when we go to reflect this one over the y-axis, You just count to see how far each point is away from the y-axis and then plot it. So we start with our vertex. Our vertex is 1, 2 away from the y-axis, so we count 1, 2. 1, 1, 1. 1, 2, 3, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3, 4. So this point right here on the y-axis, it's sitting on the y-axis. So are we going to move it at all? No, I think it's 0 away from the y-axis, so we're going to move it 0 spaces. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then this last one that's on the opposite side, you still count it over 1. And then you connect. Right. So then when we write our vertex form again, it's helpful. What's our new vertex? 2, yeah, positive 2, 6. So when we write our new vertex, or write our new equation, what's going to go on the inside with the x? Yeah, minus 2 because it's positive. Change the sign. What's going to go on the outside? Plus 6. That sign doesn't change. Which way is our graph opening? Down. So what do we need out in front? A negative sign. And there we go. You might have noticed from the original vertex up here, and then when we reflected our graph over the x-axis, what changed? Did the x value change? No, what changed? How did it change? Yeah, the y value changed sign when we just reflected it over the x-axis. What do you notice from the original to the new after we reflected it over the y-axis? Yeah, the sign of the x changed when we flipped it over the y. Just something to observe. Questions over that?
So you said over the y,
X changes, and over the x, the y changes. So whatever we are reflecting over is going to stay the same. And the opposite of that will change the sign. That's something to observe. Okay? Questions over that?